Okay, so this is the 13.3 volume of spheres. That's your standard objective to be able to find the volume of a sphere. Sphere is basically 3D, it's a ball. Okay, so it's a 3D figure with all points of the same distance from the center. So every single point here is the same distance from the center. Okay, it's a circle, it's a sphere, it's a ball. Radius of a sphere, again, is the distance from the center all the way to any point of the sphere. Again, if it goes here anywhere, I get all the points the same. Okay, this is the formula that you have to memorize, and the reason why it's like that is because if you put a ball with the same diameter, with the same radius inside of a cylinder with the same diameter, you will be able to cover 2/3 of the sphere. Okay, so 2/3 of the cylinder, no, the sphere, but the cylinder. So 2/3 of the cylinder actually are covered by the ball, by the sphere. Okay, and then the height of the actual cylinder is 2 radius. Okay, so if I were to do that, I have 2/3, right? And then remember, I'm gonna use the same like this. Okay, so the same formula that you use for the cylinder is pi r squared times height. Okay, so I have this here, so I have it here, and so it's 2/3 of that. But then how do I find my height? By doing 2 times r, 2 radius, okay, diameter basically. So I need to combine this two together, so I go 2/3, and I'm gonna move that around. Okay, r squared. So then I multiply this straight across, so that's 4r third, and then I'm gonna combine my radius. Okay, so that's 3 to the third power, so I erase this, and that becomes a 3. So that's how you get this one right here. It's okay if you don't understand this as of now. It's just an explanation of how we get the formula. So let's go ahead and do this. So the only thing you're gonna do is you're gonna plug in your values. So you have it like this. I'm gonna go 4/3 times 3.14 times radius is 2, so 2 to the third power. Okay, remember this is not 2 times 3, this is 2 times 2 times 2, which is 8. So I'm gonna plug that in my calculator. I recommend that you guys keep it as a fraction. If you do it, that's when you're gonna get a little off. So I'm gonna open parentheses. I'm gonna say 4 divided by 3, close it, times 3.14 times 2 to the third power. I already know what 2 to the third power is. It's 8, but other than that, you can also use this little feature right here. So if I go there, I'm gonna write 2 and then move it and then do my third power. Okay, and that should give me the answer. So this is volume is approximately 33.49, and these are inches, so it's cubic inches. Okay, the other way to do it, I don't want to confuse you, but you can also do 4 pi r to the third power divided by 3, which is essentially the same thing that you're doing right here. So look, if I do that, I will go 4 times 3.14 times 8 equals divided by 3. I end up exactly with the same answer. So whatever works for you guys, that's what you do. Okay, now if I'm given a diameter of a sphere, I have to be careful because I cannot use diameter for that formula. I have to use the radius. So I'm gonna go 4/3 times 3.14 times, I need to half that, so half of that is 3, so that's 3 to the third power. That's actually 27, because 3 times 3 is 9 times 3 more 3, that would be 27. So I'm gonna plug that in. I like this method better, but you guys can use that as well. So I'm gonna do 4 times 3.14 times 27 equals divided by 3. Volume equals 113 and 4 hundredths, and then we'll call it inches, cubic inches. Again, if I do it this way, I open parentheses 4 divided by 3 times 3.14 times, again, I can use this feature right here, 3 to the third power, and I end up with the same exact answer. Okay, let me give you one to do. Okay, go ahead and give me the volume of a cylinder, of a sphere with diameter of 10 centimeters, and then go ahead and give me the volume of a sphere with the diameter, with the radius of 4 centimeters. Okay, be careful. Remember, you cannot use diameter in the formulas. You have to use the radius. On this one, you have to have it. Okay, God bless you. Bye.